Hello. In this session we are going to talk about Johansen test of cointegration. Here we have the three variables: GDP, foreign direct investment, budget deficit. For the period 1971-2007, which is 37 observation. In order to estimate Johansen test, we have to check the following step. All the variables in the model must be stationary at level, which is IO, or at first difference, which is I1, or mixed at level and first difference, but not at I2. Second, we have to determine the optimal lag length for the model. And third, let me just show you here. And third, we have to perform Johansen cointegration with the above lag. If there is a cointegration, meaning that all the variables move together towards the long run association, then we can perform vector error correction model. If there are no cointegration in the variable, and the variable they are not moving together towards the long run equilibrium, we have to estimate unrestricted VAR model, not vector error correction model. Then we have to perform diagnostic tests, such as serial correlation. The model must be free from serial correlation, free from heteroscedasticity and arch effect. Then the data or the variable will be normally distributed. So what is our plan? Our plan here, we have to go to the EViews. This is EViews. This is the variable here, as you can see it. We can run Johansen test at level, or sometimes you can use only level. So here the variable we can see GDP, foreign direct investment, budget deficit. We'll open it. We'll open the data and click OK. This is the variable we have, 71 up to 2007. We have three variables: GDP, foreign direct investment, and budget deficit. Now, to run Johansen cointegration test, we have to go to Quick, Group Statistic, Johansen cointegration test. And this is the variable at level. Always when we run cointegration or Johansen test for cointegration, we have to run it at level, or the original data without difference, without log, and then click OK. Here we have the default lag interval 1 to 1. Let me put it 1 to 2. And later on in next video we are going to show you how to determine the lag length criteria. Put it 2. So we leave everything as it is. We select number 3, intercept, no trend in cointegration equation, and test var. Here the criteria, the critical value is 5%. Everything seems okay, so just click OK. Then yes. Here the outcome for Johansen test. We have 2 criteria here, as you can see it. This is the outcome. The first hypothesis, this is all hypothesis, null hypothesis. The first hypothesis, none, at most 1, at most 2. So the hypothesis none, meaning that there is no cointegration. So we cannot accept the model, but we have to check. P-value is 0, less than 0, or sorry, less than 5%, or the trace statistic 55.04 greater than a critical value 29.97. In this case, we can reject null hypothesis because trace statistic greater than a critical value or p-value less than 5%. So here we can say that we reject null, meaning that in this model GDP, as you can see it here, foreign direct investment and budget deficit are cointegrated, meaning that these 3 variables moving together in the long run towards the equilibrium. This is the result of a trust model. Here we can see these 2, one trust, and then we can go, we discuss. So what is the hypothesis now? Our null hypothesis is there is no cointegration. If there is no star in it, none, it means there is no cointegration. When we find the star in the top, we say there is cointegration because trace statistic for greater than a critical value or p-value less than 5%. The alternative hypothesis, there is cointegration. So if we reject null hypothesis, it means there is cointegration. And here we can reject null hypothesis because p-value or the probability less than 5%. Now, as you can see, this is the first test. And here, as we mentioned that, in the second hypothesis, at most 1. I'm talking about this is if without a star there is no cointegration, if with the star in the top there is cointegration, and you can see here a trust test indicate 2 cointegration equation at 5% level. This is 1, this is 2. So at most 1, meaning that there is at least 1 cointegration among the 3 variables such as GDP, foreign direct, and budget deficit. In other words, there is 1 cointegration equation. This is the null hypothesis. You can see the trace statistic, as you can see it here. The second one, 20.08 greater than 15.49, and p-value less than 5%, and this is significant. It means there is a cointegration, mainly when we find the star here. But at most 1 without the star, there is no cointegration, because we cannot decide unless we compare trust statistic with critical value or p-value with 5%. Then we can decide whether there is cointegration or there is no cointegration. So in this model, there are 2 cointegration models. So what is our plan? As I mentioned, our plan is if a trust statistic is less than 5%, less than critical value, if this one less than critical value, we should not reject null, rather accept null, there is no cointegration. But if trust statistic greater than critical value or p-value less than 5%, then we can say that we reject null hypothesis, meaning that all the variables are cointegrated. So from the p-value decision here, you can see this is p-value less than 5%, meaning that we reject null hypothesis, meaning that all the variables are cointegrated, meaning that there is 2 cointegrated equation, or there is 2 error term, the same. So the decision of a trust statistic that variables are cointegrated, there is 1 error correction term or correct the error. Now, we move to the second statistic, which is here, as you can see it, max eigen statistic. We have the same explanation, none, there is no cointegration. At most, there is at least 1 cointegration equation. At most 2, there is at least 2 cointegration equation. But how we can decide? Can we decide there is cointegration or not? Yes. If we find the star here, the same as we discuss it here in TRAS, we can say max eigen statistic 34.96 greater than 21.13, which is cointegrated, and p-value less than 5%. So we can say there is 1 cointegration equation in this model, meaning that all the variables moving together towards the long-run equilibrium. At least 1, also there is 17.93 max eigenvalue or statistic greater than critical value 14.26%, and p-value less than 5%. So here max eigenvalue test indicate 2 cointegrating equation at 5% level. This is what just simply how to explain how to run Johansen cointegration test, and how to explain or interpret the 2 value of TRAS value and max eigenvalue. This is the explanation here, the same as what I just mentioned. And then if we go down to the EViews, and you can see here, this is the normalized cointegration equation. And this equation here, many of the researcher or the student actually confused to interpret the long-run equation. The long-run equation, which is usually, to interpret this equation, we have to reverse the sign of the coefficient and their effect as the independent variable on the dependent variable. For example, for indirect investment, this is the coefficient minus 0.48, and this is budget deficit plus 0.42. How to interpret this? Now this is negative, we have to reverse it. We can say foreign direct investment positively affect GDP by 0.482, while budget deficit positive, so negatively affect GDP by 0.4249. And this is the interpretation for the long run or the normalized cointegration coefficients, which is usually we use it in the reversed in the long run, and the sign of the coefficient are reversed in the long run. So in this case we can say there is, but if there is no cointegration, we can run only short run var, not long run vector error correction model. Thank you, and see you for the next video. Hello. Today we are going to talk about vector error correction model, which is VEC model. And this model, as we mentioned in the previous video, and please watch the previous video for cointegration, Johansen cointegration test, and proceed to estimate the vector error correction model if there is a cointegration. As we mentioned in the previous video, there is a cointegration, or there is a long run association between the three variable GDP, foreign direct investment, and budget deficit. As far as there is cointegration, we can run vector error correction model. So in this video, I'm going to run vector error correction model and test it. We have to specify in this vector error correction model, we have to specify the dependent variable. Here we can put GDP as a dependent variable, and foreign direct investment here, and budget deficit as independent variables. We have to select the first model, because when we run the vector error correction model, we have to select the first model with GDP as dependent variable. How to test it? Let me go to EViews. This is the data, as the same data as before in the Johansen test, 1971, 2007, 37 observation. And here we have the three variable. We can select the GDP first, foreign direct investment, budget deficit. We open it as a group. This is the data we have. To test vector error correction model, we go to quick, estimated var. Here you can see standard var and vector error correction. We select vector error correction model. GDP as a dependent variable, as we mentioned before, foreign direct investment independent, budget deficit independent, and then we select, because we have, when we test cointegration, we find the cointegration between the three variables. So we have to select vector error correction model. We leave everything as it is, and lag we mentioned in the cointegration 1 to 2. Now press OK. This is the output. This is the output for error correction model. From this we can just here, because there is no p-value, we have to find the p-value, because here we have cointegration equation, as you can see it here, and this is vector error correction model. Let me just show you here. This is in this cointegration equation and long run model. This is error correction model equal intercept, GDP lag 1, foreign direct investment lag 1, budget deficit lag 1, and error. From this, we can estimate the error correction. This is the error correction equation, which is error correction lag 1, GDP lag 1, foreign direct investment lag 1, and budget deficit lag 1. Here you can see this is the error, this is the standard error, and this is the t-value. If we divide coefficient by standard error, we get t-value. Coefficient by divided by standard error, we get t-value, and this is the constant. As you can see it, we replace it here 5.385, and this is 1 for GDP minus 1, GDP minus 1, which is lag 1, this is 1, and this is for foreign direct investment, O minus 0.48, and this is for budget deficit plus 0.242. Now we'll go to this equation here, what we have here. When we construct the model for error correction model or for the cointegration, you can see here, we can say this is a vector variable. GDP is a vector variable, GDP, foreign direct investment, budget deficit, because these three equations represent a systematical equation. And the first equation we said GDP is dependent variable and all these is independent variable. The same thing for foreign direct investment, dependent variable, and this is all independent variable, and budget deficit dependent variable, and all these independent variable, which is systematical equation. Because when we say systematical equation, it means that the dependent variable and the independent variable, it could be dependent and lag 1. So now this is the equation, cointegration equation. This is the error correction model, and when we find p-value, we can see this is if negative and positive and statistically significant, we call it this is the adjustment towards the equilibrium. Now let me just now find the p-value, because we cannot, here we can find t-value, coefficient divided by standard error, t-value, coefficient divided by standard error, t-value, and so on. Coefficient divided by standard error, we get t-value. But we want the p-value. How to get the p-value in order to interpret the result? I'll go to proc, make system, order by variable, and here we have, as we mentioned, systematical equation, three equation. I mentioned before that we take the first equation, because first equation was GDP is the dependent variable, and foreign direct investment, budget deficit is independent variable. So the coefficient here, as you can see it here, when we say cointegration equation, and this is the error correction model, represent all these up to here. This is all represent the adjustment towards the long run equilibrium, or the long run equilibrium if it is negative and significant. So in this case, we select this one here, this equation, copy this equation, go to quick, estimate equation, paste it here, and here we have to run it. The option is okay, everything okay, leave it as it is. The specification of the model, this is the model, and just press OK. When you press OK, you can see here the p-value created. And this is the error correction model. You can see here for the first equation, for this equation when GDP is dependent variable, this is the equation. And this is error correction model, intercept on all these short run coefficient. And this is the probability, p-value, for all the variable. Now we have the error correction model here, minus, which is good sign, and this is significant, which is good. This means that for the interpretation, the error correction model is the adjustment towards the equilibrium for the coming years, or the adjustment towards the equilibrium represents 22.88 for the equilibrium. So the model will be adjusted by 26.88% because negative sign and significant. And this is the constant, as you can see it here. Here we can look at the R. R we can look at it is low, but if statistic is significant. Let me show you this part here. And R square is low and statistic is less than, meaning that the independent variable R jointly can influence the dependent variable. And here we have to see that foreign direct cannot cause GDP, but budget deficit can cause GDP. This is the causality in the short run. We shall use wild test. So how to use wild test here? Okay, now I go to view, because here just I want to mention the wild test to see whether these variable foreign direct investment C4 and C5 cause GDP as a dependent variable in the short run or not. And then budget deficit C6 and C7 can cause GDP in the short run. So I'll go to view, coefficient diagnostic, wild test, and then we have to put the null hypothesis for foreign direct investment. I mentioned that this is here up to here, up to here. This is long run error correction model. This is what we find here from the error correction from this equation C1. This is C1 up to here. And then we have to test to see whether C4 and C5 foreign direct investment can cause GDP or not. So we have to type it C4 bracket equal C5 bracket equal 0. This is, we call it null hypothesis. This null hypothesis, we have to test it. If we reject null hypothesis, it means foreign direct investment cause GDP in the short run. If we cannot reject it, we accept null hypothesis and reject the alternative, it means GDP, foreign direct investment, cannot cause GDP. So let me just run it and see the result. Press OK. Here you can chi-square corresponding to p-value. Here the p-value 87.12%, greater than 5%. So we cannot reject null hypothesis. We cannot reject this variable 0. So in this case, foreign direct investment has no cause, does not cause the GDP, as we mentioned here. This is the result. As you can see it here, 87.12 greater than. We cannot reject null hypothesis, rather we accept it. It means that meaning that the coefficient, sorry, typing mistake, the coefficient of foreign direct investment equals 0. Therefore, we can say there is no causality from foreign direct investment towards GDP. So foreign direct investment cannot cause GDP. Now we have to test for budget deficit. I'll go back to the EViews. I'll go to view, coefficient, wild test. See, we said here C4, C5, and C6. As we mentioned, just I want to show it to you. C5, C6, and C7 for budget. So we go to view coefficient diagnostic, while test coefficient. So C, as we said, 5 equal C6 equal 0. This is the null hypothesis, sorry, C, this is a bracket, C5 equals C6, which is here, C5 equals C6 for the budget deficit, and this is the null hypothesis. The same interpretation, if we reject null hypothesis, it means there is a causality between budget deficit and GDP. If not, if we cannot reject null hypothesis, it means foreign direct investment has no effect, or the foreign direct investment has not caused GDP. Let me see the result now. Press OK, and here you can see chi-square corresponding to p-value. P-value is 0.44%, which is less than 5%, meaning that C5 and C6 not equal 0, which is the alternative. So in this case, we can say, as you can see it here, budget deficit equal, which is less than 5%. In other words, p-value less than 5%, meaning that we reject null, and we what is null? Null is there is no causality from, sorry for the typing mistake, budget deficit towards GDP, while the alternative means there is causality from from budget deficit towards GDP. Here, budget deficit can cause GDP. Now, after we test the while test and we find the short-run causality between the foreign direct investment, budget deficit, and the dependent variable GDP. Now we'll go to the diagnostic test. We have to test serial correlation. We have to test serial correlation, heteroscedasticity, arch effect, and normal distribution. And the rule is, if the null hypothesis, because here there is a null hypothesis, when we test for serial correlation. Let me go to EViews, EView residual diagnostic serial correlation. We leave it there, lag as we mentioned in the beginning, 2. So press OK. Now here observed R square corresponding to the p-value. P-value greater than 5%, 13.28 greater than 5%, meaning that the model is free from serial correlation in the test of Prouch-Godfrey serial correlation LM test, meaning that the null hypothesis is the model has serial correlation, has no serial correlation, and the alternative, the model has serial correlation. So if we reject null hypothesis, means the model has serial correlation. But if we accept null, we cannot reject null, because p-value greater than 5%, we can say the model is free from serial correlation. The same thing for heteroscedasticity. Go to view, residual diagnostic, heteroscedasticity, and then press OK. You can see R corresponding to p-value 25.76, which is greater than 5%. The model is free from heteroscedasticity. The same thing we have to test for arch. And in arch we have to go to the residual diagnostic, heteroscedasticity, arch effect, the number of lag 1, leave it 1, and then R square corresponding to p-value, which is 44.28 greater than 5%. We accept the null and we reject the alternative, meaning that the model is free from the arch effect. The last thing we have to test for the diagnostic, the normal distribution. I'll go to view, residual diagnostic, histogram normally distributed. We look to the Jacobra probability, which is 72.73, greater than 5%, the model or the variable are normally distributed. Now, if we want to look at the model to see whether this model is stable or not, which is the what we are looking for. I'll go to view, stability, diagnostic, recursive estimate ordinary square only, select cause and test, and then you can see here, this is the blue line lying between these two lines. This is, we call it 5% significant level. This is the border, 5% significant level, and the line is lying between, meaning that the model is stable. But we want to test another test for square. Stability diagnostic, recursive estimate, we select cause of square test. We check. We can see the same thing, the model is stable because lying between these two significant level, 5 level of significance, so the model is stable. This is what we have to, because we have the cointegration, we use the error correction model, but if we don't have the cointegration, we cannot use error correction model, because these represent, these models represent the Johansen cointegration test and error correction test. Thank you for being with us, and I hope you will see the next video. We are going to talk about different material for the cointegration and the EViews software. Thank you, and see you next video. Bye.